Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Once again, we are going to complete uh, the training for this particular week. We started the week by introducing for you the different areas that you are going to tackle. We have said first week for specialization, first week is going to be construction in Oman, and then structural analysis and design in week number 2, which is next week, advanced design and structures, highway design, concrete, and then construction sites. And lastly, we are going to complete with project management. Um, in the last 2 days, we were talking about different things in construction in Oman. First day, we talked about Oman standards and regulations. What are the standards and regulations we should follow? We took some basics of the construction drawings that are used here in Oman. And then yesterday we talked about the different construction stages for a building, starting from the mobilization and ending up with the final painting or the boundary wall. And we have learned how to read the different layouts. We have learned as well what's the meaning of an inverted beam, what's the meaning of a sunken slab, a hidden beam, when to use a hidden beam, when to use a sunken slab, when to use an inverted beam as well. Today we are going to go mainly for the detailing and basic estimation. Now, as you have already knew the regulations, you have basic information or a basic knowledge on construction drawings, and then you have taken basic knowledge in the layout for the different members. The next step is to understand the detailing, so you will be able to do the basic estimation. So without the detailing, without the understanding of the layout, without understanding of the drawings, you cannot do the estimation. Uh, that's one major thing that you need to understand. Okay. Normally, one basic question or few of the basic questions that they are asking in each and every specialized interviews are going to be about how to read a plan. They'll be bringing for you a plan, and they'll be asking you now, what can you tell me about this plan? What are the things shown here? What's the meaning of this PP? What's the meaning of HP? So one of the regular questions, especially if you are working with a contractor or a consultant. And then for the estimation as well, one of the major questions that are asked, if you have a column of this number of size or this size with this number of bars and this link, how would you collect it? How would you quantify the quantities? So we'll do the estimation. Okay, so today we're going to go for the detailing and the basic estimation. Today a bit is going to be detailed. Um, if you feel that it is too much for you, or I'm talking in a fast manner, let me know, so I'll slow up and repeat whatever I have kept. If you have any question, you can write them down in your notes, and then in the question and answer session we are going to tackle them. So today we are going to take around half an hour in the detailing, and then 1 hour or 1.5 hours in the basic estimation. We are going to learn how to do the basic estimation, the concepts behind them. uh, I'll show you in Excel as well that I have made, and then I'll show you how we can save our time by using software for the basic estimation as well. Okay, so going for the first part, which is detailing. Okay, we have actually different detailings for different members, starting with the slabs, beams, columns, foundations, walls, stairs, and then finally the elevator. Now, in your design of structures, you might be dealt, or you might have dealt with the basic detailing. which is referring to the steel, how you put the steel. So أغلبكم يعني درستوا how to draw the basic detailing for the slabs, beams, columns, and foundation. But you didn't take anything related to walls. I don't think that you have taken anything related to stairs and an elevator as well. Okay, going for the slabs. Now, I'll show the pictures first. I'll explain what is this condition, and then we'll go through the different things inside this particular case. Okay. So this is representing a simple. This is representing a simple supported end, where or a discontinuous end in the slab, where you can see that this is the last support. We don't have any other support in this particular area. Okay, so this is going to be representing an end support case for you. Okay, and in end support case, whether it's a simple supported slab or a discontinuous slab, you should know that the moment in case of a discontinuous or in case of a bending moment, in case of a simply supported slab, sorry, you should know that the bending moment is parabolic. It's a parabolic, and at the end where a discontinuous joint or a simply supported joint, the bending moment is zero. But we cannot if the bending moment is zero, normally we don't have steam because the moment is zero. But we don't forget that we require to have a good connection between the slab and the beam supporting the slab. If you don't have any connection, each and every element is going to deal by its own. For our case, we want the slab to be fully connected with the beam. That's why we are, even if the moment is zero here, we don't have a negative moment. It's not like a continuous where we are going for a negative moment and then positive moment and then negative moment. Now, if it's a negative moment, we have normally top bars. If it's positive moment, we are going for bottom bars. Now, in case of a simply supported, it goes from zero and then parabolic curve to zero once again. It means that all the reinforcement are bottom, since there is no negative bending moment. Now in this case, even if there is no negative bending moment, we need reinforcement for the connection between the slabs on the beam and the beams, whether it's simply supported or a discontinuous case. So what we need to do, we need to provide a minimum reinforcement, and this minimum reinforcement has set by the code. It's different from one code to another. Whatever we are trying to illustrate for you is based on the BS code. So the BS code says for you this particular reinforcement at the top, which is the minimum, you need to provide 50% of the main. Okay, so for example, if you have uh, if you have um, 500 millimeter square in the main bars, then a minimum of 250 square should be at the support. That's 50% of the main. It means like if you have 32 32 diameter, for example, if you have 32 diameter or 20 diameter for the main steel, then we should use at least 10 millimeter for the connection at the end, which is half of the main. The main is 20, then the support is going to be around 10. Although a lot of designers, a lot of consultants are using the same diameter, because it will be easier for the contractor in the site to use one uniform diameter, especially for the same slab, because it will make a lot of confusion in the slab itself. Okay, so you can see that whatever we are having here, we have different reinforcement. Okay, this is your bottom bars. Okay, so this is your bottom bars, this one. Okay, this is representing your bottom bars, and you can see this bottom bars goes, or this bottom bar goes from here. Of course you cannot see the other bars which are behind. So this bottom bar goes from here, and then it will end up here. So this is going to be the first bar that we are talking about, which is the the main bar, which is normally, if this is a short direction, so this is a short main bar. Okay, short main bottom bar. And then, so this is the first part. The second part comes from here. Okay, so this second part, this comes for the top bar. It goes from here till the upper side. Okay, so if you see now, we have two reinforcement, two separate reinforcement. First reinforcement goes like this. Reinforcement goes like this. This is going to be the bottom. After that, we are going to have the top starting from here, going for the top portion. Okay, so to make it a bit clearer، الحديد هذا اللي موجود هنا، الحديد الطولي، في عندي نوعين من الحديد، اللي هو الحديد على شكل كرة والحديد الطولي اللي موجود longitudinal, and we have the transversal or main and the other direction or x and y. Okay, so هذا الحديد اللي هو بشكل طولي, this is your main. So this is your main bottom. Okay, this is your main bottom. After that, we need to have the connection reinforcement between the slab itself, this is the slab, and the beam. So we need to provide reinforcement which is called to be the minimum or top, which starts from here تبدأ من هنا and it goes to the top. Okay, we said how much is the value. The value is going to be first 50% of the main. So إذا هذا مثلا 500, this is going to be 250, this is 500, this is 250 as minimum. Okay, what's the length that we need to provide? Okay, what's the length that we need to provide? The length should be, okay, the length should be, first here we need to have the lab. You can see that في نقطة تقاطع بين هذا reinforcement والreinforcement الثاني. Okay, so this reinforcement goes from here to here, والثاني يبدأ من هنا and goes to the top. It means that this portion is an intersection area, اللي هو نقطة تقاطع بين reinforcement اللي تحت والreinforcement اللي فوق. And this we are calling it to be labbing. That's why it's written for you that this is going to be labbing. How much is the lab? It depends on the diameter. You should have studied in the design that we have different labbing values, whether you are talking about tension reinforcement, whether you are talking about compression reinforcement, whether you are referring for 460 or you are referring to 250. All of that thing will disturb the value of the lab. Some of them are using it to be in the side, some of them are using it 40 diameter or 50 diameter. So if my diameter is 10, then this should be a minimum of 50 millimeter or 40 millimeter. That depends on the consultant himself. Okay, and then we will continue from this particular lab till this portion, which is the center. Okay, till this portion, which is the center, and then we'll have this hook. Okay, we'll have this hook. So the center is clear. This is going to be approximately from the lab till the support around 25 millimeter according to the code, and then once again from the face of the support لحد النص عندي, and then we are going to have a hook of normally around 7 of diameter. So this value is around 7 of the diameter, and then the top portion is going to be one fifth of L, but it should not be more than the LD, which is development. So when you go for the code, you will have two values normally in a table. One is called to be lapping, another one is called to be development lap. You can refer directly to 1/5 of L. So if your L, the span between one support to another support is 5 meter, then we can go and have this one to be 1 meter, which is fifth of the 5 meter, going to be around 1 meter. Okay, and then the circular reinforcement here are the other side. So these are representing the long side, okay, or y direction reinforcement. So here this is x reinforcement for the bottom, this is y reinforcement for the bottom, this is x reinforcement for the top, this is y reinforcement for the top. X refers to short, y refers to the top. Now, why this is very important for me? Because when I go and do the estimation later on, I should know what's the total length of this particular bar. If you don't know that this length goes from here to here, knowing that this slab is having this value, and then 7 of diameter is having this value, and 1/5 of the length is having this value, you cannot add them together. If you cannot add them together, it means that you cannot find the total length of the bar. If you cannot get the total length of the bar, you cannot get the reinforcement, because the reinforcement depends on the length of the bar and the diameter as well. Okay, so one basic thing that you should know, that we have a lapping, which is whether it's 50 diameter or 40 diameter. Normally the consultants will be mentioning them in the general notes itself, and then this is, as we said, approximately according to the code, is going to be 7 of diameter. There is one case for 90 degrees hook, and there is one case for 180 degrees hook in the hole. So this is around 7 diameter. So if your diameter is 7, this goes to be 70 millimeter. And then we have here the 1/5 of the span. Whether your span is 5 meter or 4 meter, you need to take 5 meter divided by 5, or 4 meter divided by 5. Okay, going for the second case, or this is what we have tried to explain for you. This is the bending moment diagram, where you can see that the bending moment diagram for a simply supported is going to be 0 here, and it's going to be 0 here. If it's 0, it means that we don't need to provide reinforcement. But in reality, when it comes to site, to ensure that there is a connection between the slab and the beam, we need to provide a top reinforcement, which is shown here. Okay, going for the going for a continuous element, where you can see this is representing a end support or a discontinuous support for me. This is a continuous support, and this is another continuous support where it has been cut here. Now what you can see, we have already described this particular thing. If you can see, this is what we have described, that this is going to be the short bar, this is going to be the long bar for the bottom, short bar for the top, long bar for the top. And we explained the lab, we explained the 25, the 7 of diameter, and then we explained the 50%. Now the other scenario is going to go here in this particular area. Okay, in this particular area. Okay, so in this particular support, we need to understand, okay, we need to understand that there is a support. The support will go from where to where exactly. So this is there is a support, but we need to know the reinforcement will go from where to where exactly. So this is going to be my support. First thing, I'll be making the reinforcement. Since it's a support, if we go and see the bending moment diagram, we can see here that we have a negative bending moment here. That's why we supplied, even if it's a discontinuous case, we supply a fixing or a connection reinforcement here. For the intermediate support here, what do we have? We have bottom reinforcement. So we supplied in this particular region, we supplied bottom reinforcement. So top, bottom. For the bottom, even if there is no bottom here, you need to supply bottom. Okay, so bottom is not is not discontinuous. الحديد حتى لو ما عندي، او الحديد السفلي او البوتم reinforcement، حتى لو ما عندي bending moment في هذيك المنطقة، we always put it from the beginning till the end, from the beginning of the slab till the end of the slab. Why? Because the area here is very small. Okay, the area here is very small. So instead of cutting the reinforcement and then fixing it, and then cutting the other area and fixing it, it's better to provide, it's cheaper to provide one bar from the beginning till the end. Then I'm going to save money in terms of labor, because it's a small area, so it's not going to be that expensive to be provided. For the top, why don't we provide a top? If you see, this area is not having a top reinforcement, while when it comes to the bottom, it's from the beginning till the end. We don't have any stop. Okay. Now why do we provide for the bottom? I have already explained for you. I said for you, the support region is small, so it's not worthy of cutting it. It will cost me more time, it will cost me more labor money to cut for the support, for the bottom. Now when it comes to the top, there is a big area, or there is a big space between this support and this support. Okay, it's a big area here, so it's not worthy for me to go and put the reinforcement from the beginning till the end for the top reinforcement. Why? Because the distance between them is far. So now it's more cheaper to go and cut the reinforcement. Okay. Now when it comes to the continuous support, which is here, so we have discussed already the discontinuous support, which is acting to be a simple case. We're going to go for the continuous support, where this is the middle or the intermediate support. So what we need to provide, due to the negative bending moment, we are going to provide the top reinforcement. Okay. So هذا support مالي, this is my support. Reinforcement will start from here to here, but this is not going to be sufficient, because if you see, the bending moment is not only acting at the center of the column, it extends till this position, and it extends to the other position. So what we need to do, أول حاجة, we are going to make the reinforcement here. This is the first length. Now I need to continue the length. So how to continue? I need to take from this face of the support, I need to take 1/3 of L. So 1/3 of L minus support, and then another 1/3 of L from this particular support. Okay, so what we need to do, we need to take first for the support itself, and then 1/3 from the first face, and then 1/3 from the second face. So this is going to be my top reinforcement for an intermediate support. Okay. So محتاج ان انا اعرف لما يكون عندي discontinuous support, I'm going to take the reinforcement of 1 point or fifth of the length, which is 0.2. If it's intermediate support, we are going to take it 1/3. If you return back to the code, it will tell you here, for example, that it is 0.2 or 0.15, and then here it's going to be around 0.3. Okay, so normally we use 1/5 in case of a discontinuous, and in case of a continuous support from both sides, we use 1/3 from the first side, 1/3 from the other side, and then the center for the support. All of these things are going to affect your calculation of the estimation of that particular member. So before knowing the length, you cannot go and do your estimation. That's why it's very important for you to understand the detailing. Okay. Now another case we have discussed already, a simple supported case. We have discussed an intermediate case. The second or the third case is going to be for cantilever. Now you can see this portion is not having any support at the end. Okay, so this is acting as a cantilever, fixed from this particular area, and then continues till here. Now when it comes to this particular reinforcement, I need to understand that due to the bending moment, and this is an example of a bending moment, you can see that it goes bottom here, and then we are going to go to the top, and then once again returning to the zero. So in this particular area, the bending moment is acting to be negative. It means that our top reinforcement is available. Okay, so either the bending moment goes down, it means that the reinforcement is bottom. If the bending moment goes up, it means that the reinforcement is going up. So if you can see, نحن اتفقنا انه بالنسبة للبوتر راح يكون من البداية للنهاية. We don't stop even if there is no positive bending moment هنا. بتلاحظوا انه we are supplying bottom reinforcement here. Okay. Now since the bending moment says for you and I have top bending moment in this particular region for a cantilever, we supply the negative bending moment. Okay. So one thing that you need to know, okay, before finishing the slabs, one thing that you need to know, okay, whether you are talking about a simply supported case, whether you are talking about a continuous case or a cantilever case, the bottom reinforcement will start from the beginning till the end. Okay, we don't stop the bottom reinforcement, whether you don't have a bottom bending moment like this case or not. Okay, so the bottom reinforcement is going to continue from the beginning till the end. Top reinforcement is going to be supplied wherever is required. So if I have negative bending moment, I'll go and supply top reinforcement. So in this case, we have negative bending moment here. So that's why I supplied the top reinforcement. The same thing goes here. Okay? So bottom reinforcement goes from the beginning till the end. When I have a support or a top reinforcement or a top bending moment, or uh, yeah, up or top bending moment, then we can go here and supply reinforcements for the top. Okay. When it comes to the sides, we have um, 1/5 of L. When it comes to the center, we are taking it 1/3 of L and then 1/3 of L. When it comes to the cantilever, we provided for the top reinforcement is going to be provided for the top length. I mean, for the full length of the cantilever. Okay, and then plus, to ensure that this cantilever is fully connected to the other slab, we extend the top reinforcement for the cantilever for a distance of 1.5 of L. Okay, so to summarize once again, we have bottom reinforcement that starts from the beginning till the end. We don't stop it whether we have top bending moment or bottom bending moment. When it comes to the top bending moment or the top reinforcement, whenever we have top bending moment, we are going to have top reinforcement. If we are talking about simply supported case, then we are going to supply 1/5 of L. If we are having an intermediate support, then we are going to provide 1/3 of L, and then 1/3 of L, and then the support region. If we are having a cantilever, the top reinforcement is going to go for the full length of the cantilever plus 1.5 L, which will ensure that this cantilever is fully connected to the other slab. Okay, and once again, the detailing will differ from one code to another code. Whatever we are using here is a BS code. Okay, now going for the slabs, I have spent a lot of time in slabs. Slabs are very similar to beams, anyhow, so I'll not spend a lot of time in beams itself. The same concept goes here. Uh, this is a simply supported case, so we say even if it's a simply supported case, we need to ensure that there is a top reinforcement to ensure the connection between this particular member and the other member. So in this case, beam and a column, we need to ensure أن البيم والcolumn اللي موجودات عندنا they are properly connected with each other. Why we need to do this thing? This will protect you a lot in terms of seismic and lateral loading. Okay, so the members will not deal separately; they are dealing together. So once again, what we need to provide. Okay, what we need to provide. This is a case of simply supported. According to the code, what we need to do. The code for the beams, what they have done, since the bending moment goes from here to here. You have studied curtailment in the college, which means that in this region we have small bending moment, in this region we have small bending moment, في هذه المنطقة we have huge bending moment. It means that the reinforcement required for this region is small, the reinforcement required for this region is small, the reinforcement required for this region is more. Okay, that's the meaning of curtailment. Now if you go and see what we have provided, فهذه المنطقة اللي هي representing this small area which is having a 0.1 L length. So if we have 3 meter, then this is going to be 300 millimeter. Okay, how much is going to be or what is this representing? It's representing this area for a small bending moment. The same thing goes for the other side. Since the bending moment here is small, we provide the reinforcement of 0.1 of L. Okay, and this is whatever we call it as a main bottom. So it starts from the support, it goes till the other support, even if it's at the center. Now taking into account for the center we have huge bending moment, so what we need to do, we provided the initial reinforcement which was supplied in this area and this area, and we provided extra reinforcement if it's necessary. Okay, so if you remember yesterday, we talked about bottom main reinforcement and bottom extra. So bottom extra is representing that in this region we have small bending moment, and then here we have huge bending moment. So نحن في العادة وش نسوي؟ We supply one reinforcement from the beginning till the end. If that reinforcement is sufficient, then no need to include extra reinforcement. If it's not sufficient, I'll be supplying extra reinforcement في المنطقة اللي هي فيها huge bending moment, which is represented here. Okay. And then we are going to have our top reinforcement. Okay, we are going to have our top reinforcement here. In case of in case of a top reinforcement, this is going to be your length, which is represented here as a top main. If this top main which you have supplied in this support and in this support is not sufficient, okay, if you supplied, of course, it's not going to go for the full length, uh, unless you are talking about a very small span. Okay, if you are going for a very small span, because of the small span, it might go from the beginning to the end, but normally it does not go. So we provide for the support here, and then we provide for the other support. If this top reinforcement is not enough, then at that time we are going to provide top extra reinforcement. Okay, and then the lengths are mentioned here. So for the top main, the length is going to be one third of the span. If you are talking about if you are talking about the top extra, then it's going to be one fourth, and it goes on. Okay? So what you need to understand when it comes to the beams, the first thing, we are doing a lot of curtailment. Why we are doing a lot of curtailment? We are not doing it a lot in the slab, because the bending moment for the beam will vary a lot compared to a slab since the loading is more. So what we have done for the bottom, we divided the region into zero point 0.1 L, zero point 0.1 L, and then the remaining 0.8 L. We supply one reinforcement from the center of the support till the center of the support. If that reinforcement is sufficient, then that's fine. If it's not sufficient في المنطقة اللي موجودة فيها maximum bending moment, we need to go and add extra bottom reinforcement, which is for the distance of 0.8 اللي هي المنطقة المتأثرة بالماكسيموم bending moment. The same thing goes for the top. We supply the top bending moment. I mean, since even if there is no bending moment here, we supply a top reinforcement for the connection between the beam and the column, even if the bending moment is zero. If the reinforcement we provided is sufficient, it means that we don't need to go for extra reinforcement. If it's sufficient, then that's fine. If it's not sufficient, we provide the extra reinforcement. The same thing goes for the slab. Whatever we explained for the slab is happening here. The only thing, when it comes to slab and beam, you can see that we don't have the circular reinforcement, which are the long direction. In slabs we have two direction reinforcement. In beams only we have one direction, so that's why you are not seeing the circles here. Okay, so the same thing goes. This is a support, this is a support. We provide the bottom reinforcement, but now instead of going for 0.1 L, if it's continuous, we goes for 0.15 and 0.15. So the remaining is going to be 0.7. We provide one reinforcement from the center of the support till the other center of the support. If it's sufficient, then no need for the extra bars. If it's not sufficient, for the area where huge bending moment is acting, we supply more reinforcement. The same thing goes for the top reinforcement. Okay, so خلاصته, these values are available in the code, so they will not disturb you a lot. The only thing that you need to understand, when to provide the top reinforcement, when to provide the bottom reinforcement, when do I need to provide extra top or extra bottom. So the initial thing that you need to understand, we provide the bottom reinforcement from the beginning till the end, as we say. We provide extra bottom reinforcement for the areas where high bending moment is there, if the current reinforcement is not sufficient. The same thing goes for the top reinforcement. Even if there is a simply supported case and you don't have a negative bending moment, you need to supply top reinforcement. Why do we need to supply it? For the connection between the member and the other member. Okay? If we don't provide, for example, reinforcement in this side for the top, you will see that there is no reinforcement in this region. It means that this particular is dealing separately, and this member is dealing separately, and then the other one is dealing separately. And this is what I was telling you. This is more of a labbing and this is representing 50D or 50 of diameter. Okay, so beam and slabs are almost the same. The only difference it comes to the values due to the curtailment conditions, and that we don't have the second reinforcement. This is a cantilever, exactly the same concept of the slab. Reinforcement for the bottom goes from the beginning till the end. Since it's a cantilever, we are going to go and provide the top reinforcement for the full length of the cantilever. If that top reinforcement is sufficient, then it's fine. If it's not sufficient, then we need to provide extra reinforcement here. How much is the length? The length is going to be around half of the cantilever portion. So you have studied these things, but you didn't study them in detail. Now, a lot of people will be wondering. A lot of values are here. It's very complicated to go and do the estimation. So when it comes to the estimation, now the easiest method of doing the estimation is to use the software. So we'll learn how to do the basic estimation for the different members using the basic methods, and then we'll go and see how it's different using the software. Okay. Now for the column, this is there are three cases normally for columns. You can see here, this cross section of a column is exactly the same cross section of the column. Okay. Now what happens? This is going to be the reinforcement for the column. Of course, we cannot see the back reinforcement. Okay. So this is because it's a 2D drawing. So this is going to be the column reinforcement. We extend normally by certain dimension or by certain length, and this is normally representing the tension level. So I need to check for this particular diameter how much is the tension level. I'll try to show you at the end of the session uh, from the BS code where you can calculate the tension lab or the compression lab whatsoever. Okay, so this is the tension lab. It depends mainly on the type of steel and then the diameter. Okay. Now, so the reinforcement for the column starts from the beginning till the portion of the tension lab. After we finish from this particular column and we want to do the upper columns, we need to insert the reinforcement for the second column. Now, of course, I cannot put the reinforcement above the other reinforcement. So what we need to do, I need to go and bend this particular reinforcement for the new column. I need to bend it so it will go and interact with the first one. Okay, we cannot put a bar on a bar because they will not be stable. So what we need to do, we need to bend it. Okay, and then we need to tie them together. Okay, we need to tie them together using a mesh. So here, if you can see, we bend the steel. That's why yesterday I was talking that if you have more than 25 diameter, it's going to be very hard for you to bend. So this is one case of bending due to labbing. Okay, visual labbing. This is what you can see. The labbing is occurring here. أي نقطة التقاطع بين reinforcement من القلم اللي تحت والقلم اللي فوق. We are calling it to be labbing. Okay, so this is happening if you have the same cross section from the bottom column and the top column, or the bottom column and the upper column. Second scenario that you need to understand, if we are talking about a column that is already going for the roof, there is no column at the top. Okay, there is no column at the top. So what we need to do, of course, your reinforcement now will not go up, okay, because there is no other columns. Although here in Oman, what we normally do, if there are columns, what we normally do, we normally extend them little bit. If you go to your roof, you will see that في عندكم مثل extra portion which are kept over there. I don't know whether I have pictures for that or not. I'll try to show you if there are some pictures. Okay, so extra portions of concrete are coming outside of your roof, okay, for different positions. What are these? Normally these are extension of the columns. Okay, why do we provide them? In case of that the user wants to create later on a new floor, then it's going to be easy for you to break that concrete and then do the labbing with the reinforcement. So reinforcement يكون موجود, and then I'll do the new column. Now, if you are not having that particular reinforcement, you didn't do it like this case. على اساس اني انا اعمل connection between the new column اللي هو مع الطابق الجديد والطابق النهائي اللي موجود حاليا. what we normally do, we normally do drilling. okay. so نعمل drilling، نجي نثقب الكونكريت او القلم اللي موجود حاليا but carefully you need so you will not cut the reinforcement, and then you will insert your new reinforcement. Why we are doing that? To ensure that the first column is connected to the other column. You don't want each and every column to be to be separate from the other one. You want them to be fully connected so they will carry the load, and in case of any lateral loading, one will not go on one side and the other one will go on the other side because they are separate. You want them to act as one. Okay. Now, in case that this is the roof and I don't want to construct further floors, what we normally do, regular reinforcement goes here, and then we need to supply reinforcement for the connection between the slab and the column. And once again, this is what we say, we need to ensure that there is reinforcement connecting a member with another member. So what we provide here, we provide reinforcement from this to here, from the slab to the column, with a certain labbing between both of them. How much is that value? This is going to be the tension lab, and this is a regular lab. So this is going to be around 50 diameter, and then you need to check here the tension bar is going to be how much for that particular diameter and uh, that particular type of steel. Okay. The other scenario, if we are having different cross sections. Okay, if we are having different cross sections. Now, if you can see here, the cross section for the bottom column is lesser. Is more than the top column. Okay, so what we need to do, first we provide the reinforcement uh, from the beginning till the end if the ends are similar. Okay. إذا هنا عندنا الend مال هذا الكولوم والend مال هذا الكولوم are the same, so we supply the reinforcement in the regular manner. Okay, so this is my reinforcement, and then we need to do the labbing as usual, as it is a regular cut. Now the other side, you can see that the ends are not the same. This is bigger, this is smaller. So what we need to do, first we need to supply the reinforcement for the end. Since it's a floor here, we need to do the labbing, the connection, as it is a roof column, because this is stopping here now. And then we need to initiate a new reinforcement to start in this particular end of the column. Okay, so it's like a combination of two cases. This is a combination of a regular case, which goes here, combination of column connected to the roof, not going to the other column. Okay, and then we need to initiate a new bar because we cannot put that in this area. We don't have bars. Okay, because you will end up having bars for the top column in only one region. Okay, and this is another scenario where we are having a smaller column at the bottom, top column at the top, although this is not recommended. Because certain portion of the column is taken by either the beam or the slab, which is not recommended. But sometimes when it comes to architectural purposes, you don't have the authority, or you don't have the case that you can do whatever you want. Okay, so normally column sizes are going to be the same. If they are not the same, then we need to follow this case. So you need to understand, if I have columns, they are having the same cross section. I need to understand the labbing. I need to understand how to make the arrangement of the steel for the column. If the column is not going to go for another column, it's ending up at the floor, then I need to ensure that the reinforcement goes from the column to the slab or from the slab to the column, vice versa. If we have different cross section, then I need to ensure that every case is covered, whether it's edge, the same edge of the other column, so we are having one straight like the regular condition. If it's ending up with a roof, it's not going for the column directly, then we should go and put a connection reinforcement. And then the other area where the top column is ending, then we need to make one new reinforcement the bottom column. Okay. Finally, going for the foundation. Okay, going for the foundation. Uh, Once again, foundation is very similar to the slab. So we have two reinforcement. We have reinforcement of x and we have reinforcement of y. Okay. So normally, what's the length of this reinforcement? The length of this bar is going to be the total length of the foundation minus the cover from this side minus the cover from this side. Okay. The same thing goes for the other reinforcement. How we are going to calculate it? We are going to get the width. We are removing the cover from this side. We are removing the cover from the other side, and we'll calculate the length of the bar. Okay. How much is this particular portion? This particular portion once again is going to be the same thing. I need to get the depth, remove the top cover, remove the bottom cover. The remaining portion is considered to be my length of bar here. Okay, so if I want to calculate this length of bar, I'll say if this is your length, I'll say the length minus the cover from this side minus the cover from this side plus the depth minus the cover top cover minus the bottom cover multiplied by 2 since this is one and this is the second one. Okay, this is the starter column. This is the starter column that we say depending on how much length that you are going to go for, whether it's 1 meter or 1.5 meter. Okay, and we need to ensure that this starter column will go and distribute. We shouldn't be putting it straight only. If you are putting it distributed, it means that the load is going to go and distribute. Plus, it's going to be protecting you from the shear. You studied one-way shear and two-way shear. So if there is any case of any shear, this reinforcement is still going to protect you because the load coming from the top will not be only distributed to this region, it will be distributed to this particular region as well. Okay, so we talked about the, the bottom reinforcement, the top reinforcement, I mean the bottom reinforcement for X, the bottom reinforcement for Y. We talked about the starter bars, and then this is the BCC, which is the blinding. We call it blinding concrete, or we call it as BCC. Okay. Um, this is this is an example of a combined foundation. This is an example of a combined foundation. Now, if it's a combined foundation, we don't have reinforcement only at the bottom. We have reinforcement as the top because of the bending moment. If you remember the bending moment for the what you call it, for the combined foundation, it goes up in the support, it goes down, and then once again up, and then it goes down. Okay? So we need to supply reinforcement wherever is necessary. So what we need to do normally, we provide reinforcement for the bottom according to the bending moment, and then we need to provide top reinforcement according to the top uh, um, according to the top bending moment. Now, one person will say that normally in slabs we don't continue doing the top reinforcement. I'll say normally the distance between the supports for the slab, normally they are far away from each other. When it comes to the foundation, the distances are not very far from each other. Okay? In case if they are far, the reinforcement will not go in this way. Okay, it's going to be more into isolated with bottom reinforcement only. Okay, and this is whatever we call it as the long bar reinforcement. So this is short for the top, this is long for the top, this is short for the bottom, this is long for the bottom. And once again the same scenario of calculating. I have the length, I need to remove the covers from the sides, and then I'll be able to get the length. The same goes for the what you call uh, the depth here. Just the only thing that I need to reduce the cover here, I need to reduce the top bar, the top short, and then the top long, and then I need to keep a minimum of around 25 millimeter between the bar and the bar. So this is going to be the length of this particular item. So if you want to calculate the length of this particular item, what you need to do, you need to go and take the full depth, remove the bottom cover, remove the top cover, remove the top long reinforcement, remove the top X reinforcement, and keep a distance of around 25. Okay. Now a lot of things are there when it comes to detailing. That's why it's a very complicated thing. It's a very detailed and critical thing. But by experience, by repeating, you will understand. You are not asked to memorize the values of the lengths and whatever. These are available in the codes. What you need to understand, why do we need to supply here? When do we have a combined foundation? Only with a bottom reinforcement. Normally for a combined foundation, we have it top and bottom. But when do we have it only bottom? That's only in case that the columns are very far from each other. And if it's far from each other, then it's better to go for an isolated rather than going for a combined foundation. Okay. And this is a slab on grade scheme, but we are only tackling the foundation here. And then we have the raft foundation, something similar to the combined foundation, but this is now going to go for more than more than two columns normally. Okay. And then we might be having things which are supporting the reinforcement, these are the stirrups. Okay. So it's more or less acting like a regular beam, or some are going to use chair. Okay, we call it as a chair. So the top reinforcement will be sitting on that particular chair. I'll try to show you what's the shape of a chair. So we can use stirrups or we can use chair for the top reinforcement. Okay. In case of strip foundation, the same thing that we have shown yesterday. If we have a solid block work, this is the length B. So we have a strip foundation. Um, we need to provide, normally strip foundation will come here, the foundation, this portion will come the same here as well. Okay, so it will come here, but in this case, why we don't supply the foundation in this area as well? Because we are talking about a neighbor column, okay, or a neighbor wall. So this is going to be the end of my plot. I cannot go and have further distance because it will go into my other neighbor premises. So what we need to do, we need to supply it on one side only, and we call it normally as a neighbor wall or a neighbor foundation. Going for the walls, I'll not go in details here. I'll just give you the highlights. What's the case for the wall? Okay. So in general, when it comes to wall, you need to understand the bending moment. So you will understand you will understand the reinforcement, how it goes. So normally for a wall, so we have one particular wall. Normally it has a support from this side, okay, and a support from this side, whether it's another wall, whether it's a beam. So if this is a wall, okay, normally it has what you call other supports are here, or the ends here. So what goes here, we are having top bending moment, and then bottom bending moment, and then once again top bending moment. Okay, so how to make that particular reinforcement, we are going to go for a regular wall where we are going to have the reinforcement in this way. So we have the main bar here, we have the main bar facing the sides. Okay, so this is one side, this is another side. So this is the first main bar, this is the second main bar. Okay, and then we need to supply the secondary bars here, secondary bars and then secondary bars. So it's like a slab, but it's flipped. Normally for a slab, the loading is coming from the top. Okay, the loading is coming from the top. That's why I'm providing horizontal reinforcement. When it comes to the wall is vertical, and normally the loading is coming lateral. Normally the loading for the column is coming lateral. So the main reinforcement is going to be on the sides. It's not going to be on the what you call. It's not going to be horizontal. It's going to be vertical. Okay. uh, and these are the cases. These are the cases for the column. Normally, you need to understand that more reinforcement is going to be at the end due to the bending moment diagram, uh, due to the negative bending moment diagram. Okay, so this is how it goes. Uh, regular reinforcements, main reinforcement on the sides, and then secondary, and then finally we have extra reinforcement for the connection or the end. Same thing here. So regular reinforcement, and then we have for the end regular reinforcement, and then we have for the end regular reinforcement, and then we go for the end. Okay, and normally walls are very complicated to be designed for, because most of the walls are taking horizontal and vertical loading, although their main functions are, or their main function is to take the lateral loading. Okay. Stairs. Um, this is for the stairs. Once again, you need to understand the bending moment diagram. Everything is related only to bending moment diagram, and based on it, you will understand how to place your reinforcement. Now, if you say if we have a staircase, so let's assume that this is my staircase. Okay, now what happens here? This staircase is supported, in this scenario, is supported by a beam here, and it's supported by another beam here. Okay, now if we want to make it, instead of making it inclined, we are making it straight, just for illustration, just to make it a bit easy. So what we are trying to do, so we are having a beam here, we are having a beam here, and then we are having the slab itself for the stair. Okay, so beam beam stair, or beam beam and then stair. Okay, so in order to draw the free body diagram, we are just simplifying. We are putting it beam beam and then the stair itself. Now for the stair, this is considered to be a fixed connection, this is considered to be a fixed connection. So how we are going to have the bending moment? We are going to have the bending moment goes up here, and then bottom, and once again going up. Now if I go and shift this one up a little bit as a regular stair, it means that there is a bending moment going up in this particular support, and then it goes bottom for the span, and then once again it goes top for the support. So for the ease of use for the staircase, make it straight. So you have one beam on the side, another beam on the side, and then you will have negative bending moment, positive bending moment, and then negative bending moment. Now shift it to the regular staircase, the same bending moment will come. So negative, positive, and then once again negative. Okay. Uh, how that is going to be related, you need to understand that this is going to be your top reinforcement now. Okay, this is going to be your top reinforcement for this particular. This is the region where you are talking about the negative bending moment between this and this. So this is going to be your top reinforcement, which is here. Okay, which is here. Okay, the same thing goes here. So this is going to be your top reinforcement now. This is going to be your top reinforcement, and then we have one span reinforcement, which is going from here till here, continues from the beginning till the end. Okay, so we have this as a bottom reinforcement for the slab, and we have this one as a top reinforcement, this one as a top reinforcement, and you can see it's only supplied at the portion or negative bending moment. So this portion due to the negative bending moment, this portion is for the bottom. This is going to be a landing, so we provide bottom and top. This is a landing, so we provide bottom and top. um, we provide as well reinforcement to protect our steps. Okay, so these are the reinforcement to protect our steps. Regular reinforcement with minimum bars here. Okay, just to protect the steps from major damage. Okay, but the major reinforcement for the stair that you need to understand, that we have bottom reinforcement, we have top reinforcement, and then we have the secondary as well. Okay, we have the secondary. This is the landing, this is the beam. You can see 4 bars for the beam, 4 bars here for the beam, and this is going to be the slabs one. Okay. Other scenario as well, that it can be connected to the foundation directly. Okay, so instead of a beam, it goes for the foundation. Uh, in both scenarios, it's supported in the same manner. Okay, so nobody is going to ask you how much it's going to be this length and this how much is going to be this reinforcement, because that depends on the design itself. But you need to understand that based on this bending moment, this is the reinforcement, how it looks like, whether you are talking about a slab or a beam or a stair or a wall. So the major thing is the bending moment diagram, which will be repeated mostly in each and every interview, whether you are going to be asked about the detailing or whether you are going to be asked to draw the bending moment diagram for any scenario. Okay, and this is what we say for the foundation as well. Okay. The last thing, I'll not discuss it, but just to show it to you, this is going to be the elevator or lift foundation. So a wall here. So this is more into a wall which we have shown earlier. This is another wall, and this is more into a raft foundation. So it's more or less something similar to regular raft with retaining walls. Okay, but here instead of retaining wall, we call them as shear wall because they are not retaining anything. Retaining walls are to retain something, whether it's soil or water. In case of a swimming pool, we are retaining water. In case of soil, we are retaining soil. Here we call them as shear wall, and this is going to be the raft foundation. Or instead of calling them shear, we call them normally as core wall. Core wall is a combination of shear wall. So if you have one wall only, we call it as shear. If you have more than one shear wall connected with each other, we call it as a core wall. Okay, so you should know if somebody is asking you what's the meaning of core core wall and a shear. By explaining this, we have finished. This is supposed to be having only half an hour session. I have taken around 1 hour and 15 minutes since I felt you didn't study much in the college which is related to typical detailing. I'll try to minimize the other sessions time so that you will not be ending up having 3 or 4 hours time session. Okay. Thank you very much for listening. We'll have question and answer session, and then we'll go for 5 minutes break, and then we are going to go for the second session.